Hi, everyone. Thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I'm Mike Consider-CB, a part of the product management team for Autonomous Database. And today we have a very, very cool session. We're going to talk about how to use actually property graphs and generative AI RAG models in Autonomous Database for basically data fidelity, right? So today's session, we're going to have Melliyal Annamalai. She's a distinguished product manager. And then Ganesh Seetharaman, he's an architect in the Oracle data catalog. And Melly's going to give us a quick overview of Graph first and the graph technologies. And then basically Ganesh is going to talk to us about, data fidelity, how to actually understand the criticality, right, of having data fidelity across all your data estate, right, everywhere where data is. And also, managing and also data governance, right, that is very critical for all of the AI and machine learning projects, right, down the road when you're working with that. Because if you don't have a good data fidelity, right, all of those things later on are actually potentially useless, right? So throughout the session, we're going to have an open Q&A. So feel free to type your questions in the Q&A section in Zoom, okay? We're going to have product managers looking at that. And then we're going to share with you guys some links through chat, okay? So basically, I'm going to share some links with you guys right now. So if you look at the chat, we're going to have some links there that are pointing you guys to the Get Started with Autonomous Database. If you're not familiar yet with the technologies, we have links to our, LinkedIn group there, to X, and then to where you can ask your questions, right? So you can go either to Stack Overflow or to Slack, right? So the Oracle developers, there's a Slack workspace where we have an Autonomous Database channel there that you can just go in and ask your question directly, okay? So feel free to do that. All right, so excellent, guys. So thank you very much. I really appreciate it. So Melly, what I'm going to do is I'm going to just stop sharing my screen and let you start sharing your screen. And thank you very much again for joining us. And thank you, Melly and Ganesh. I'll stop my screen and Melly will start, right? Thank you.
And welcome, everyone. It's great to be here. And thank you, Marco, for the post. That was really useful. And we are delighted to have Ganesh speak about how they're using graphs in their service to keep track of data lineage. So since about, I think 50% of you said you're not familiar with graphs, let me just take 2 to 3 minutes to just talk about graphs and what you can do with graphs in Autonomous Database. So graphs help you make your relationships in your data more explicit. All data has relationships. When you make these relationships explicit, you can ask more interesting questions of your data. Like Ganesh will be sharing the things that they can do by making their data lineage information modeled as a graph. So some other examples here in financial transactions, it's very interesting to see whether a bank account is connected to other bank accounts. And this could be by just a transfer of money. Maybe there are specific patterns in how money is moving between accounts, which can help you identify things like money laundering or maybe some other fraudulent activities going on. In manufacturing, it's very interesting to look at how your data is connected. Typically, this information and in the previous information, typically this information is stored in tables. You have components, you have subcomponents, and you have parent components. By this thinking or looking at the data as a graph, you can find out more easily dependencies to answer questions such as, if I change the design of a particular component, what is the impact? What are all the components that will be impacted? So I can decide what would be the cost impact and other types of impact. Social network analysis. Social networks are naturally a graph. So you can analyze your network to see who's following whom. And more subtle kinds of analysis, such as who is connected to influencers. I mean, finding out the influencers is one thing, but then finding out who are the people connected to influencers, and so on. So you can do many different things when you kind of view your data as a graph. So we have customers from many different domains. I talked about financial services. Manufacturing, let me just talk about maybe telecommunications, where you model your network towers or network towers as a graph, and then you can say that if there is you can do what if analysis. These are the towers that are in the path of a hurricane, and when how should I reroute my signals because these particular towers are affected. Or I want to understand by doing graph analytics, I want to identify vulnerable points in my infrastructure. So a lot of signals are flowing through a particular node. So I want to know what I need to do to ensure that that particular point is not so vulnerable. So there are many, when you think about it, many different use cases where it's really helpful to model your data as a graph. So what do we have for graph support in Autonomous Database? We have comprehensive support for modeling your data as a graph and then running graph queries on this data. So that we talked about patterns, like I was talking about money laundering and whether two accounts are connected to each other. You need the language to specify that query. And that is supported as part of Graph Studio in an Autonomous Database offering. And Autonomous Database, always free, now available with 23 AI, has support for writing graph pattern queries in SQL. And Graph Studio and Autonomous Database also includes over 80 graph algorithms. PageRank is a popular one, which helps you identify, like in the social network analysis, who are the people connected to the influencers. So they might not be connected to many people, but if they're connected to an influencer, that makes them an interesting and important person in your social network. So there are many different graph algorithms that you can use and you can invoke with the Python or Java API. And one of the main advantages of using graphs in Autonomous Database is that you can create a graph view on data in tables. So often data is stored in tables, business critical data is stored in tables. You don't have to move this data to a separate schema or a separate database to create a graph from it. You can just create a graph from data that is stored in tables. So the data can remain in place in the tables and you just create a graph view on that. And we have tools for automated modeling of graph creation and also an advanced notebook with integrated visualization. I have here an example of a graph query and the resulting visualization of the results. With that, I will turn it over to Ganesh.
And thank you very much. That was great, Melly. There are already a couple of questions for you there in the Q&A. So thank you, Ganesh.
Thanks, Marcos. Thank you, Melly, for that intro on the property graph. Welcome, everyone, to this session on data fidelity. I want to introduce myself. My name is Ganesh Seetharaman. I'm the architect for Oracle Data Catalog. In this session, what I want to do is I want to talk about data fidelity, maybe spend a couple of slides on explaining what we really mean by data fidelity here, the properties or the qualities of data fidelity. And then I want to maybe do a small intro to the data catalog use case on why it's important for the users of data catalog to understand their data. And also, I want to spend some time explaining how we leverage the property graph for data lineage, and then talk about the use of large language models and neural search in answering data fidelity related questions to our customers. With that, I just want to say that data fidelity, it's probably one of the most important things in an enterprise because it has a profound impact on several things, right? The most important thing here is the data complexity. And what I mean by that is, it's the difficulty in working with data because you don't know what data you are accessing. The formats are all over the place. It's non-standardized. You cannot trust data coming from certain sources. That makes the data architecture also very complex because the applications, whether it's analytical applications or ETL applications or ML applications that you have to use to access this data, they have to have access to clean data. So it's important to have control on the data fidelity. Without it, things can get very complex very fast. So I want to introduce maybe a few terms that in the course of this conversation on data fidelity, when I refer to completeness or accuracy, I want all of us to have a shared context on what this really means. When we talk about data accuracy, I'm talking about data is actually, validated, certified, it's verified, there are no inconsistencies in the data. So this is the common, standard understanding of accuracy, generally in the data world. Completeness, right? So incomplete data it's a frustrating, whether you're using it in ML apps or you're using it for analytics, right? So because key signals, if they're omitted, provide an incomplete picture of your business, and more importantly, even if you know key signals are missing from your data, the real question is that what do you do about it, right? So do you impute? Do you generate data? Do you use profiling to find data patterns, and then you use you fill the data based on those value patterns. So these are very complex topics. It's not in the scope of this discussion, but I just want to point out that the completeness is one key aspect of data fidelity. And latency, right? So is the data arriving on time in your warehouse or for your dashboards, right? So if it's not a fresh data, you may be looking at incorrect information. And relevance, right? Without context, data is really not worth much, and that's true across the board, right? No matter what applications you use data for. Compliance and access, this is a very common topic. You share data, you own data within the enterprise. There are different owners of the data. They all have controls at various levels. Some of them have fine-grained control. People use Ranger, people use databases. Other times data is in object storage, no fine-grained access control, only coarse-grained. And then you have various actors who access data. Some of them part of your business, some of them outside the business. You create sanctuaries, you share the data by replicating it. There are exfiltration of data that happens for this purpose. So there are a lot of things going on there in terms of compliance and access, but you need to keep an audit on what you do with your data, who you open it up to, and so on. And of course, data about data, right? So here, there are things that you know because you explicitly harvest at source. There are things about the data that are decorative, that are annotated. People tell you as part of the curation. So you need to be able to distinguish and add different weights to this information available about data. That also is a big vector along which you can understand data fidelity. And obviously, the processing aspects, right? So people create interesting zones on their lakes. For example, you have a raw zone, landing zone, transient zone, analytics zone, curated zone, syndication zone, and so on. So these are some of the, when we refer to untrusted trusted metadata, this is what we mean, for example. That's why I want to quickly introduce these terms to you. What I will do now is maybe spend 2 or 3 slides in quickly introducing what the data catalog is. As you can imagine, it's a cataloging of data, and by cataloging we mean collection of metadata in a central place. It's a metadata dictionary, if you will. That spans the entire data estate of your enterprise. Why is it important? It's important because users want to find the right data for their analytics, for their dashboarding visualizations, for their queries, for their ML models. So how do people find data? They come to their catalog. They search for the data. And the second part of the use case, why people use catalogs, is because people upload data to the lake, and when data lands on your raw or transition zone, it's difficult to understand because it could be various types of data, unstructured, semi-structured, structured. It could be, the format could be all over the place, Parquet, ORC, Avro, CSV, TSV, and so on. And also, before the data is curated, it's difficult to make sense out of the data because it could be high-dimensional data with so much information that most of them may not even make sense to you at all. And also, you need to understand how the data is governed within the enterprise. Who owns the data? Who should you ask for permission to access the data? How do you relate the data in terms of the business concepts? Do you know it's a customer's data? Do you know it's a relationship data? Do you know if it's a geography data, and so on? So that's why people access the data catalog. There's a term that we use in the data catalog. The term is data assets, right? A data asset, you can think of a data asset as an instance of a data repository, right? This is an object storage bucket. This is a database. This could be your MySQL instance. This could be your Graph DB. This could be your file in a Google Drive. And they are harvested. So we go to the source and try to understand how the data looks like, the shape, or the type of the data. So when I say data asset or source, it simply means an instance of a data repository. That's what the context I typically use for the term data asset or source. So I just want to skip through. We already talked about this, right? Discovering data, the unified metadata catalog. And what I mean by this one is that not just for the design time, but also for query engines like Spark, they need an operational metastore, right? So your catalog doubles up not only as a design time back and I find a data set to use for my MLOps, but it also is used by a Spark engine to basically understand what are the data files that constitute this table, right? So when you query against a table in the object storage, the Spark engine comes to the catalog or the metastore. And the most important focus here is the data fidelity and data quality issues, right? So how do you basically use a catalog to find out these issues? With that, let me go and talk about the data lineage. So I want to spend a couple of slides very focused on what we mean by data lineage. There are 80% of the definitions are industry standard. There's nothing remarkable here, but there are some variations on what people think is a data lineage. But I just want to keep the focus on when I say data lineage, what I mean by this, right? There are three characteristics that we consider to be important for data lineage, right? The source that contributes to data. We need to know where the data is coming from. The type of operations that is performed on the data. So you need to know what type of transformations, cleansing, enrichment, normalization, standardization you perform on the data. It's very important to understand all these operations that happen on your data. And also, more importantly, you need to know the targets, right? Where is the data moving to? Who is consuming it? Is it protected at all points where you syndicate or stream this data? So these three things, right? Where it comes from, what is being done, and who is consuming it. To me, these are three central pillars for data lineage. Now we get into the details of some interesting characteristics of lineage itself. So there are people generally, when they talk about lineage, they talk about the horizontal lineage, right? How data flows from point A to point B. But then there's also an interesting vertical lineage, which is how the attributes of an entity or a data set are transformed and information flows downstream, either through derived metrics or expressions that are we can say these are formulas to compute something, So that's what I mean by a vertical lineage. These are very interesting because you can double click on it, drill down, and try to understand how, for example, a profit is computed, and why certain derived metrics are basically not the values that you expect. Then you want to drill down and see what's happening there. But the flow of if you level up, then you see the horizontal lineage, right? So when we talk about horizontal, vertical, we talk about breadth and depth. And also, not all lineage metadata are equal, right? Because here I just want to separate out two interesting aspects of lineage data. One is the descriptive lineage. These are things that are defined in an enterprise as part of working with data, pipeline definitions. That is a source for lineage, and that I would call a descriptive lineage, right? Also, business lineage, your applications that basically say, okay, the data is coming from ad spend, it's coming from audience engagement, it's coming from marketing campaigns. Now, these are interesting details on where the data is originating and where you pick up this lineage information from, right? But mostly these are user created and curated, because the fact that that is the pipeline design doesn't mean the data has already started to move through that pipeline, right? So it's one thing to know that, okay, so this is the one possible way data can flow through the system, but we don't know for a fact that the data has actually moved through that pipeline. The automated lineage, this is where the rubber meets the road, right? So you create a pipeline design. Now you schedule and execute this pipeline. Once you execute a pipeline, once you execute a query, you know for a fact, based on the logs, that the data has actually moved through the system, right? So this is basically the execution graph DAGs that, for example, a Spark engine would output as a lineage, right? Now, this is more trustworthy because we know that data moved through the system, and we have an audit to prove the data actually moved through the system. So descriptive, automated, and that's basically the difference. That's the way we see it. In the catalog, a majority of the information comes from the automated lineage. We collect the data from query and application execution engines. So I just want to maybe spend maybe 30 seconds on this one. This is a typical usage on how people work with data lineage. People harvest data assets. These are sources. Now, the lineage is actually generated by data pipelines. In the catalog, we use the OpenLineage format. This is an industry standard for capturing lineage. Generated lineage from these Spark applications, say, or SQL, or from dbt, whatever the tools they may use to wrangle data, transform data, that output is actually harvested by the catalog, either through a push architecture or a pull architecture. We'll talk about that. And these are very detailed lineage. We will get a column level, expression level lineage on how this data is moving through. And then when people use that, for example, visualization or a dashboard in Oracle Analytics Cloud, they will know where the data came from through this lineage. They can double click on looking at the source of this data, the transformations done on the data, and so on. And then obviously people use it for identifying, has there been a compliance violation? How is the fidelity of my data look like, and so on. Quick introduction on the automated lineage. So your data pipelines, the Spark applications, are queries executed in compute clusters. This is generating lineage. And there are sources that are, for example, this could be, your line of business users who are telling you, well, I have my own Spark cluster on the side. I did something. I ran a Python code, or like a Scala code, or a Spark code. I want to tell you something about what happened with this pipeline. So we collect, in the former case, this is the automated lineage. This is the descriptive lineage. So these come to us, and we normalize this lineage in a format, the OpenLineage format that we actually understand. And we run it through our metadata service, validating and reconciling all references to all data within the enterprise, and then feed it to our system where this data sits in our domain models, and we basically have a property graph view that define all this data. So one of the interesting cool things we love about the property graph is that I don't need to create a separate database to look at this data as a graph data. I can just simply superimpose a graph view on top of my data. So my entire data with this relationships looks like a bunch of edges and vertices, and I can just run graph queries on top of the data. So that's the cool part. No replication, no need to periodically update, and none of that stuff. This is basically how we consume. We have a lineage service. We expose a bunch of APIs, and in our UI you can see Lineage as well. So you can, if you're an Oracle Analytics Cloud customer and you have a visualization or a dashboard, you can say, hey, I'm using this table. Can you give me the lineage for this table? We send you back this payload, which is the lineage metadata for this table. Why are we using property graph? Why not just simply use relational database and address these user queries on data fidelity and lineage? Relational models simply won't scale. The scale or the volume of the relationships that we capture is really big. There are a lot of upstream downstream dependencies. So typically you have pipelines that are triggering other pipelines downstream, triggering other pipelines. By the time the data is syndicated or published to your visualization, you're probably going through 5, 6, 7, 10 stages of cleansing, transforming, normalizing, curating, enriching data before it's available. So it's and upstream downstream dependencies on what functions you're calling, what pipelines are waiting for your data to be made available. That's just too much dependencies to capture and reason over, right? Impact root cause analysis, you're probably familiar with this one. Path analysis, about how the data is flowing through the system. What are the interesting incoming edges? Third-party data I'm actually feeding as part of the system, and I'm using to finally shape my data that is used in the visualizations. Pipelines can have hundreds of entities, thousands of columns, 10,000 columns, in some cases 10,000s. And we capture a lot of information. Each edge is actually very, very interesting for us because the time of execution for that application, execution type, is it a Scala code, Python code, is it a Spark application, is it a query, is it a DDL statement? What is the task type? Who owns that code? What is the execution status? Is it been failing frequently? Is it always running? What is the cadence of the run? And that information, edge, which represents the flow of data from point A to point B, is it trusted? Did we collect it ourselves from a known compute cluster from which the information got published to us? Is it some third-party person who is telling us, trust me, this is what happened to the data? So we can assign weights on the information that we handle here, right? So it's very complex. And also some of the other interesting considerations, right? So relationships can be analyzed very differently based on several factors, right? Weights associated with these edges. You can ask questions like, hey, what dashboards are impacted if I blacklist, if I find that a data set is compromised? If my data is always arriving 30 minutes late, what can I do to my pipeline or my path to get the data faster? What do I have to compromise, right? And also, what part of my dashboard is actually trustworthy? Are there visualizations that is getting data from systems that does not enforce rules and constraints, right? So you can say that, well, 67% of my data I know is highly conformant, and the rest 33% I have no idea. What happens to this data? You can look at the path traverse, right? You can ask questions like, okay, so can you tell me data sets that had risk of exfiltration along its path? when the data was processed in my enterprise, right? You can also ask questions like, okay, is anyone that I'm not aware of, who is not part of my organization, has access to intermediate entities that I'm staging, right? It could be in object storage for briefly 30 minutes before it gets picked up by subsequent downstream processes. You can also make some very interesting inferences based on distance between vertices, right? So you can, for example, simply say that the longer the distance between two vertices, which are both data sets, the more convoluted or more complex, more resource consumption that happens to process the data, right? So there are very interesting things. When you look at a graph, it completely changes the way you look at data, both in terms of the cost that your business is actually spending to get the data and how valuable the data is, and also the risk of the data being used for purposes that you are not aware of, right? So those are some of the interesting things that we really are fascinated. We want to basically expose to our customers, and that's why you use Property Graph. More data points on why we want to use Property Graph, frequency of failures, some of the information that we have as part of the graph that says, like I pointed out, these are manual data movements. People said that, yep, this is me uploading the data, trust me. So we need to know this edge cases. Also, one of the interesting things is that when you look at the vertices, right, you will tend to find some clustering of vertices. There are data that are created for reasons that may be very interesting to you. These are interstitial entities that are very ephemeral, may live in the cache, in the Redis cache, for example, 20 minutes because they want to be picked up by other pipelines. They want to use the data, right? So you're like, okay, so do I need to really keep this when I reason over this graph? Can I collapse this subgraph, maybe simplify my graph to look at this differently? Or are these clustering of these vertices where I see so much fan out happening here very interesting to my understanding of the data and so on, right? So you can make very interesting inferences, ask very interesting questions on how data is being processed, right? So I want to just maybe skip the rest of the stuff in the interest of time. There are so many declarative metadata we have as part of the Lineage Graph. We have user tags that are carried over, custom properties that are defined on attributes and tables that we carry over, profiling information of value distributions of a table, quartile definitions, standard deviations, means. Those information are actually carried over, digital fingerprinting or data fingerprinting. RBACs defined on source, column level security defined upstream. For example, you secure a column upstream, the data flows downstream, that it is not secured. Guess what? Your governance rules would say, well, because the data was secured upstream, was only allowed access to certain roles and certain types of users, they're going to enforce the same security downstream as well, right? So Graph allows you to propagate or transitively derive context and security details about data that you won't otherwise be able to, right? Of course, classifications, you can propagate classifications downstream. So Property Graph is knowledge graph. Without Property Graph, there's just no way you're going to make sense out of how data flows through your data real estate, right? So that's the bottom line. Now, let me quickly talk about the lay of the land here. So as you know, we have business metadata, which is the glossary, ontology, vocabulary. People use different terms. These are business concepts that we basically allow you to model in the catalog. So you can group them as a semantic model, right? This is for people who are familiar with the analytics universe. This would be your logical layer or your presentation layer, right? These are visualizations, dimensions, levels, hierarchies, fact tables, derived metrics, measures, all this information. And then you have technical metadata. This is your physical metadata, right? These are the tables, files, external tables, other data artifacts that you harvest metadata about, defined through data assets. And then you have the lineage model, right? This is, like I said, this is the one that, you understand, we collect through automated lineage, comes to us from query engines directly. we trust them, assuming those query engines actually run under the infrastructure layer that is within OCI. There are query engines that contribute this data that comes from outside. So we take that information with a grain of salt. But overall, we have a lot of information about Lineage, how the data is flowing through the system. That's our domain model, right? And then we define a property graph view. This is the graph view on top of the domain model. And we index this data. That data is being used by OpenSearch for semantic neural search, traditional search. We have our recommendation engines that tell you, hey, maybe you need to categorize this data as customer data. This is a campaign data, right? So this is driven off of all this information. And then we all have a large language models. I'm going to quickly talk about how we basically infuse context through the property graph in our large language models. This is again how we actually use or leverage lineage metadata to infuse context. So typically, when people talk about retrieval augmented models, right? One of the things they talk about is they talk about mostly a system which is pretty much standard, right? So you have basically user queries or prompt engineering, and then those are being embedded, and there's a query rewrite to basically ensure that you're semantically more coherent or closer to the data on which you are trained on, the corpus of data that you actually indexed. So this is the harvested metadata, right? This is the data assets data, right? This is the tables, partitions, views, columns, constraints that we harvest from everywhere. It's being indexed into the OpenSearch. The OpenSearch also doubles down as our vector database. So typically, when you ask a question about, hey, is this a customer data? Is profit derived? When you ask questions like that, those questions are actually reasoned over by the large language model based on, all the generated documents from our harvested metadata, where we say, this is the customer table, these are the attributions of the customer table, and so on and so forth, right? So what do you basically get back traditionally in a typical RAG model universe? Is the response to your question on is property a derived metric, right? So it'll give you a response saying, yes, property is a derived metric, blah, 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 right? So that's basically how it works. But what is the big downside there, right? The big downside is that no context. There's no substantiation or explainability in terms of, okay, why do you say that? Why do you say the property is a derived metric, right? Well, that at that point you see the limitation of not using a knowledge graph, because the relationships in the knowledge graph is so important in understanding why you get certain answers, how those answers could be explained or substantiated based on the information that you captured, right? That's where context is everything, right? Without context, information is useless. That's where the lineage property graph comes in, right? With this indexing, this metadata, right, into our vector database, it's changes the landscape completely on what is possible, right? What are the questions you can ask about your data? So I talked about this, right? So when you, without the lineage graph, without the context, you're going to see that the simple vector generation with documents indexed from your corpus of information that you generate based on the harvested metadata, there you cannot make inferences because you don't propagate information, right? It's almost like a neural network. You're propagating information from point A to point B in a context-sensitive, highly relevant fashion. That is not possible without a graph database, right? And also, the ranking process for determining relevancy, right? That's unclear. So you have a whole bunch of documents, all things, they're all equal. there's just no way for you to basically say, okay, the reason why I say this is a derived metric is based on my ranking, and my ranking is based on the 3 pipelines from which I got the lineage metadata that I know is current, it's running today, it's executing at a shorter cadence, it's being used by X number of visualizations. So you have all these data points that you say that that's why I think that this is actually a derived metric that's being widely used and accepted within the analytics universe in your enterprise, right? So also outside of lineage, there are no really complex, interesting relationships that we capture. So that is very critical. That's why we also want to feed the knowledge graph to the large language models. And anytime you index documents that make you think that all things are equal, and you focus only on semantic similarity, not on relationships that are weighted, right? Then you really are missing out on what is possible, right? So lineage graph, it provides us the crucial element in reasoning over information, and that's context, right? Explainable relevance. Why we think 2 things are actually connected, right? And why that connection is validated, why we think it's can be used, and why do we associate more weight on those connections to make some inferences. So that's the knowledge graph's power, right? So today, in the catalog, you visualize lineage. We use PGQL to retrieve this information. We present it to a UI renderer, so exactly how data flows from sources. What are the tasks that operate on this data, and then what are the downstream interstitial entities or persistent entities that get stored this information, how the data moves to the target. This is the typical upstream downstream lineage visualization you would see in the catalog, right? So far so good. This helps you to understand. For a bank customer table, I can see that the upstream tables are this, and I do some data loading task and so on and so forth, right? But so I'm going to skip this one in the interest of time. So I want to actually focus on this data fidelity aspect, right? So typical search, you would say, hey, I want customer data set for use in my for analytic dashboard I'm building, right? So you get like 15, maybe 150 different query hits, search results, right? But how do you rank it? So one of the interesting things here is that that's a traditional question you ask, okay, what data set to use? But you can actually ask a more complex question. What attributes can I use to calculate employee turnover rate? Here's the missing information, right? So for example, it says based on, so the large language models itself understands employee turnover rate in terms of separation date and hire date, right? But the thing is that it also knows that none of the lineage graph tells you that the separation date as an information was being captured. So it says, I don't know, because you don't have separation date being, it is not even mentioned anywhere. So you're not, so this is a missing data. You're actually missing out. So I don't think you can calculate employee turnover rate until you bring this information over, this employee separation date, right? So you can, now you see where, instead of asking a traditional search question, you can ask a much more loaded question which can give you a more relevant, specific answer on what information you actually need to capture to get some insight about employee turnover rate, right? Another question that you can ask in general, is there any PA data that's being made accessible or made available to someone outside the organization? So you can go and take a look at some of the syndicated or published data sets and say, I see that these attributes are actually qualify as PA data based on the classification that actually flows through the lineage graph. and I see that you syndicate this data, maybe you are exposing PII data as part of this, right? For example, or you can say, we can be even more specific. Instead of being PII, you can say, so obviously, there's no magic in people using large language models to basically say PII means, SSN information, bank account, credit card information, your address value, live, and so on and so forth, right? But here, you can be even more specific and say, do I use SSN or social security information ever in my pipelines across the entire data estate? That question can also be answered, right? It's one thing for you to know that there are tables that has SSN information, but another to know that is actually it's part of a data movement. And some of these tables actually may end up outside your safe zone, right? Not secured and sitting on data sanctuaries that may be exposed to third party, right? So, and also, one of the interesting functionality we are actually exploring right now is the ability to basically generate pipelines. So you can actually say, hey, can you generate a SQL to calculate promotion cost during a specific period by channel, by region for certain customers or for this marketing campaign, right? So I believe that one of the most powerful thing is going to be, SQL was obviously an awesome, beautiful language to express, the information you want to get out of something. But if you provide a natural language interface or a conversational interface to, generating code, deploying a pipeline, or asking questions about the way data is being used in enterprise, that would be really, really awesome. So that, I believe, is the future, and we are actually getting there very fast. So that's the other promise of basically, using knowledge graph and large language models to get to this promised land. So I think that was my last slide. There are some appendix, but let me just stop here because we have a few minutes left here. So I'll stop sharing.
Thank you. Thank you very much. That was great. Really appreciate it, Ganesh. So we had a few questions, right? I think Melly can go through them with you.
We have a few minutes. I'm just going to pick a few questions. Ganesh, one is, can we ingest data live into your service?
So the data catalog itself is not so we obviously have other products where you can stream data in, right? We have, for example, data flow, which supports streaming of data that you can process. The data catalog itself can model that streaming source as a data asset. So for example, if this is Kafka or this is your an event publisher, and that can be a data asset to the catalog.
That makes sense. Okay. And then there was an interesting question around, can data lineage differentiate between data sources, that is, whether it is AI generated data or, I guess, non-AI generated data? I mean, I don't know, you need magic for that.
Yeah, so there's no magic here. I mean, I would say that this is the same issue with content that you consume, and this content could be from a bot, could be from somebody. It's tough to tell, but the real problem when people started to use more and more data generators to fill sparsity in the data that they have, missing data, right, is that they tend to use data characteristics like, the distribution of values, and then generate data that fits that, traditional, no outliers, but fits within the standard deviation, right? Ranges where they want to generate. Is it generated? Is it captured? It is tough to tell. I think that's going to be one of the key challenges if a data that is generated is actually generated by AI or not. So I don't have an answer for that.
No, but I mean, you kind of alluded to some ways in which to think about it, right? The standard deviation, where it falls in distribution. So that's helpful. So is everything that you showed in this session generally available? Everything is GA, I believe?
The use of there are some parts that are still being worked on. So I would recommend you to visit the data catalog page the Oracle Cloud OCI data catalog page and see what we have. And then reach out to me, and I'm happy to talk about what are the things you're working on currently.
Another thing related to the service, do you gather information from services like pipeline information from services like AWS Glue? And does the pipeline have to call data catalog with the OpenLineage REST API?
Yeah, so right now, that's the restriction we have. So the lineage that we collect, so there are things that we go and collect ourselves. For example, if you're using the data integration service within OCI, we go and collect the lineage ourselves. You just have to set it up and say, this is my source that I want to collect lineage from. But if you're using something like Dataflow, it's also a simple setup. You can publish lineage information to the catalog. If you're an external metadata provider, your Glue Glue ETL pipelines running in AWS, you want to publish lineage metadata to the catalog, you can do that. We have APIs that allow you to push those lineage metadata. So yeah, we have both push and pull models. We support pull models for some sources that we know, and that's within OCI. The push model is for everybody else.
And do you also include what are the plans for including those the Golden Gate data dictionary and all its pipelines in the catalog service?
Correct. Right. If you have a replication pipeline, extract and replicate, you're using flowing data between this, you can tell data catalog that between these two assets, that data at the edge is basically a Golden Gate replication that's happening. Yeah, so it's part of the push that you can define.
And it's a request for a live lab or like a how-to so they can try this service. If you have any resources, well, I'm sure we can
reach out.
Share.
I'll put in touch with
Ganesh.
Yeah.
And I know we have exactly 2 minutes, so this is again a general kind of I guess open-ended question. How exactly is the lineage graph used for ranking documents in a RAG system?
Yeah, so I can maybe try to answer this question by saying that the relationships, connections, or the edges that basically flow between the vertices in the knowledge graph. There are two important aspects, right? So one is basically the properties on these edges themselves, right? And for example, these are the properties that say that this is a data movement path that we have audited, and we know that this is running at a let's say this is scheduled periodically gathering data and so on. So we know that there is something that's more which has a higher weight than another edge or connection that's a descriptive lineage, which is things we have been told, but we are not able to substantiate or ascertain ourselves. So there's no audit or traceability about that descriptive lineage, so we associate less weight. So when you ask questions about something, we would obviously rank based on things that we absolutely know to be factual, and obviously the other information is ranked lower, and we will only answer questions that are based on things that we can substantiate.
Makes sense. Thank you very much, guys. There are more questions coming in, but I think we have to wrap it up here. So over to you, Marcos.
Thank you very much. Thank you, Melly. Hey guys, so I'm gonna make sure that the questions are answered and we send you guys back answers by email. All right, so again, I would like to just thank you very much, Melly and Ganesh. The presentation was great, lots of new information. I am sharing, guys, the links again, just in case some people are asking about recordings and things like that. So make sure you come back to the link that I'm sharing there in the chat right now. And when you go back to these Learning Lounge, right, this is where you're going to see the recording. So you're going to see links, you're going to see the recording, the videos, and then upcoming sessions, okay? So make sure to register for the series, all right? Okay, so having said that, again, thank you very much, guys. I really appreciate it. I'm going to just leave this channel open for a few more minutes. If you guys have more questions, please type them in. Okay, I'm going to make sure that we answer your questions here. But I'll leave you guys to some music here at the end. And again, thank you. Thank you very much again, Melly and Ganesh. I really appreciate it.
Thanks, Marcos. Thanks, Melly.